Today we're going to get some more practice in interpreting linear functions in some real-world situations. We're sticking with the same form we've been working with, which is y equals the rate of change x plus the initial value. One thing we are going to do a little differently today is start switching up our letters so we don't always use X and Y. Sometimes we use letters that are more specific to the problem you're working on. So like using D for dollars, or we'll see in another example P for profit, or T for time. We switch up the letters sometimes, so we'll get some practice with that today. Another thing we're going to get some practice with is picking out words that mean rate of change. So there are some important signal words in a word problem that tell you that you are looking at rate of change. The most common ones I can think of are per, each, and every. And those words signify that you have a value that depends on something else, and that's going to be your rate of change. So take a second to write down this first example if you need to pause. We've got Manny has a part-time job as a waiter. He earns $45 plus $8 per customer in tips. So in his job, he's earning a steady $45 just for working. And then for every single customer, he gets an extra $8. Our initial value is going to be the number that doesn't change. So in this case, the 45 is our initial value. And the reason that's our initial value, again, is because that is the starting amount that he makes. No matter what, he's always going to make that amount. Even if he is there all night and there's no customers, his job is paying him $45. So that one is our initial value. And then our rate of change, so one of our signal words was per, he gets $8 per customer. So the amount of money he gets in tips depends on how many customers there are. So that's our rate of change. That's the amount that is not steady because it depends on the number of customers. So there are two things we're looking at here. We're looking at how much money he makes, fancy word for that is income, and then we're looking at his income based on customers. So in my equation, I'm going to define my variables. I'm going to let I be his income, which is based on C, the number of customers. So for our purposes, income is like the Y value. That's the result based on the X value, how many customers there are. So when we write this equation, we're going to write it as I equals 8X, or 8C, we're using C instead of X, and then plus 45. Now, there's nothing wrong with sticking with X and Y, but you'll see some problems give you different letters, and I think it's good to get practice and to get in the habit of understanding. We might need to read the problem to figure out what each letter represents. So now that we have an equation, we can use it. First one says, how much money does Manny earn if he serves 14 customers? So customers is represented by C. So in my equation, I'm going to replace the C with a 14. So his income is going to be $8 for each tip for the 14 customers, plus the $45 that he makes no matter what. And so now I'm going to use my calculator. My variable's already isolated, so I'm just kind of number crunching. We'll follow order of operations and do 8 times 14, which is 112. Still need, so that's how much he got just in tips, the 112. And then we still need to add the $45 he makes in addition to that. And when we add 45 to that, we should get 157. So he is going to make $157 if he serves 14 customers. In number 3, it says, how many customers does Manny need to serve in order to earn $205? So that's how much income he wants for this problem. So in my original equation, I'm going to replace the I this time with a 205. And we're solving for how many customers that would take. And now from here, When we solve this equation, we're trying to get C by itself. So we do that by isolating the variable and removing addition or subtraction first. So I had that plus 45. So to get rid of it, I'm going to do minus 45 on both sides. And 205 minus 45 is 160 equals 8C. And now to get C by itself, we divide by 8, since 8C means 8 times C. And I got C equals 20. So what that tells me is that if Manny serves 20 customers, he'll get $205. So now let's take a look at another example. Again, pause if you want to copy the problem down and don't have it printed out. It says John mows the lawn after school. He finds that he can use the equation P equals 15L minus 150 to calculate his profit, where P is the profit and L is the number of lawns that John mows. So this question's a little different. It actually gave us the equation. P equals 15L minus 150. And just like we did before, it tells us what the letters stand for. P is his profit, and L is how many lawns he mows. So we've got some questions to analyze the equation. The first one is, what is the starting amount, or your initial value, and what does it mean in the context of the problem? So in my equation, my initial value, or my starting amount, is going to be the number that's not next to the variable. So this is the starting amount. And what that means, so that's a negative 150. There's a minus in front of it, so we do have to write that as a negative 150. What that means in the context of this problem, so think about it. If he starts with negative $100 is the units that we're working with. If he starts with negative money, that means he has spent money, right? So if we think about starting your own business, you might need to buy some supplies, some materials, some tools, whatever you need. And so he's actually out money when he starts. So we could, in this problem, say that John spent $150 to get supplies for his business. We don't know what they are, but he had to spend some money to start. Maybe a lawnmower. So when you think about, like in a real world scenario like this, when you spend money to then get like money in your pocket, the profit, you have to make back what you spent and then earn even more. So he's starting $150 in the hole. The rate of change in our equation is going to be the number next to the variable. So in this case, it's 15. And so if we notice, that's 15L. So 15 times the number of lawns. So our rate of change here is 15. And that's going to be the amount he makes per lawn, or how much he charges for each individual lawn. So then we can use that equation, again, to analyze what's going on here. How much profit does John make from mowing 23 lawns? So we're going to use our equation. We have the number of lawns, which is an L in our equation. So we say P equals 15. Replace that L here with a 23 minus 150. So your variable's already isolated, so we're just doing our number crunching. So 15 times 23 is 345. So what that tells me is if he makes $15 for every lawn and he did 23 lawns, these people are paying him. In total, he's receiving from his customers $345. But when we want to analyze his actual profit, then we have to subtract out the $150 he already spent, and that gives me $195. So while his customers have paid him $345, his true profit is only $195. And in this last problem, it says how many lawns does John need to mow to make $450 profit? So here, they gave us a profit value. So in our equation, I'm going to replace the P with 450. And we are trying to solve for L, get that L by itself. So away from the L, we move any addition or subtraction. So I'm going to add 150 on both sides. That would be 600 equals 15L. And then we need to divide by 15. And 600 divided by 15 is 40. So he needs to mow 40 lawns if he wants to make a profit of $450.